So let's move to lab assignment 8. So basically, in this, they are talking about recursion and some general problem with array. So let's see. You guys all know array, na? It has been taught in your class, right?
Yes, sir.
Yeah. So we will take some questions in today's lab. Okay. So this is one simple question. Uh, you are given an array nums of size n. Okay. So there is a term called majority element, which is basically the element which appears more than n by 2 10. Basically, there is floor function of n by 2. I think you know what is floor and seal. Uh, you must assume that it always exists, that there is a majority element in a array every time. So you have to find that majority element. That is the question. And you know about time complexity and space complexity. How many of you know about this? Okay, only few people. Fine. Anyway, uh, let's assume here. So first, I will take some example. Like if this is a my array, two, three, two, two. So this is an array of 6 elements. Okay. So what is the majority element here? Obviously, two is occurring 4 times, so two is the majority element. So like this, you have to write a program. So why don't you try it first, and then we will discuss how to do it. Okay. So everybody, please try this question. This is a simple question on array. And if anyone has any doubt in question, like you are not understanding what is it, you can ask. Ignore this as of now. Order and an order one, because most of you don't know about it. Okay. Uh, so anyone who has done it? Okay. So any idea what how you think you'd proceed for this question? Anyone? Okay, fine. Let's see. So what would be the first approach here? You don't know that the maximum limit of elements, right? If it is, it could be the maximum number should be int max or anything. So you just can't make an array to take all the numbers. Okay, there's a limit that you can make array of around 1 lakh or something, but you can't make an array of infinite numbers, right? So there has to be some approach. So one very trivial approach is you sort the array. Okay, so when you sort the array, uh, you guys know how to sort the array. It has been taught bubble sort, insertion sort, and all. It has been taught in your class. Am I audible? Anyone? Hello?
Yes, sir, audible.
Yeah. Okay. So is sorting been taught in your class? What that was I'm asking. Okay. I think you're not responding to this. So basically, sorting is you are arranging the number from increasing to in an increasing format, but non-decreasing format. That is all. So if you have to sort this array 3 to 2, 3 to 2, then its sorted array would be 2, 2, 2, 2, and then 3, 3. So after you have sorted the array, you have to find the majority element. So one thing you can do basically that if you start with a number like if I write the pseudo code of it, n is total number of array, total number of elements in array. Okay, so just take a count, like let's my majority number is something, let's I started with -1 just for namesake, and it count is 0. Okay, so when I uh, first I take majority number at the first element of array, right? Num sub 0 and count is 1. So I am already taking the first element, that this 2, by assuming that whichever first element it would be, assuming it to be the majority just for now, and its count is taken as 1. Okay. So then I started with second element of the array. So first I will check if it is equal to the previous element or not. Now, if it is equal to previous element, then you will increase the count. Fine. And if count is greater than, you would simply return the number nums of I, because that is one uh, which is going to be a majority element. Wait, there is some disturbance. Yeah, okay. Now see, if the number that you are traversing is it does this two here. Now, if you compare it with the previous element, then obviously uh, the same number is has occurred again. So you just increase the element of number of count here, count plus plus. Now this is the frequency of the element. Okay, so you take if count is greater than 4 of n by 2, then you have returned that number. Now, what if the current number is not same as the previous one? There could be a possibility. So what would you do is basically you will change count to 1 and count to 1 and majority equals to nums of I. So one thing is for sure that if once you have found a majority element, then you are simply returning it here. Now if you haven't found it yet, now let's see, if instead of this array, if we had uh, 3 as majority, okay, then the sorted array would be like this: 2, 3, 3, 3, 3. Fine. So what would have happened is the count of here is 2. Okay. Now it should be greater than 3, right? So when you come to I equals to 2, I equals to 2, that is element 3 is encountered, then what will happen? That it is not same as previous one, then it will come in this else part, and you just simply put count is equals 1 and majority, assuming that let's for now majority is element 3 here. Okay. Now whenever this you go to I equals to 3, then I equals to 4, then I equals to 5. That is all. Okay, so every time you go, the count value will be incremented every time. Okay, so count equals to 3 for I equals to 3, like this. When I equals to 3, basically once you approach this element, then value of count is 2. Then once you approach this element I equals to 4, then the value of count will be 3. Then once you approach this last element, then the value of count will be 4. Okay, so once count is 4, every time you are checking here, if count is greater than 4 of n by 2, and then you are simply returning it. Okay, so that was one basic approach to solve this question. I will tell one efficient approach also. So anyone has any problem in this approach, like how we are doing it?
Sir, I have a doubt, sir.
Okay.
Sir, it will only work for two elements, two distinct elements in an array.
No, no, it will work for every element.
Sir, if I take seven elements
Okay.
and the first three elements are two, and then 3, 4, 5, 6, 7.
Okay. So basically 2, 2, 2,
Yes, sir.
then 3, 4, 5, 6.
And
These
3,
are
4, 5, 6.
seven.
Then they max. Then the majority element is 2, but it is less than n by
It
2.
will not. It has to be greater than n by 2. What is n? N is 7 here.
Yes,
Okay. 7 by 2, or
uh,
floor of 7 by 2 is 3.
6.
So
Yes,
there has to be one more occurrence of 2 for it to be majority.
yes, sir.
Okay. So yeah, it will work for every case. Any more doubt in this approach? Okay, fine. So let's move to another approach. So what we did in the previous one was we first sorted the array. Okay, and then we have done this code. After sorting, this logic is applied. Now, can we do it without sorting the array? Like take this example: 2, 3, 4, 5, 6. It is sorted. Let's change it. Okay. So yes, we can do this without even sorting the array. So let's see how we're going to do. So the simple approach is, in the question it is given that majority element always exists. So it is guaranteed that there is an element which is going to occur for more than n by 2 times, right? So we have to leverage over this condition. So what we'll do is, let's see. The pseudo code would be like, first we will assume some element as majority, random. Let's say it's -1, and its count is 0. Okay, we are just initializing this variable. Okay. So now let's discuss first approach. Now what we'll do, we'll assume majority to be the 3 in first when we encountered 3, and we will change the value of count to 1. That is fine. Okay. Now what was the value of count initially? Initially count was 0. Okay. Then we encountered 3. Our loop is at I equals to 0. So 3 has been encountered. So whenever count is 0, it basically telling us that uh, till now, whichever element was majority element uh, should not be considered anymore as of uh, because we have encountered some another element here, because count was 0. So what we will simply do is we will change majority element to 3 and count to 1. Okay. Now when we encountered, we go to the second element of this loop. And now there comes the 5. Now is 5. Now what was our majority element? 3. And now the element that we have encountered right now is 5. So is 5 equal to 3? No, definitely not. So what we will do is, basically we will not assume 5 to be an majority element because the value of count is 1. Okay. So what we will do is we will simply what we'll do is count plus equals, if count is equals to majority. Okay. Like if majority is equals to nums of I, sorry. Okay. We are applying this condition that if the majority element that we have till now is equals to the current element, then what we will do is basically uh, we will add 1, and if majority is not equals to nums of I, we will simply subtract 1. This is ternary operator, you can see here. Basically it checks the condition. If it is true, then this one holds, which is after question mark, and if it is false, then after colon will hold. So it basically tells that if majority equals to nums of I, then count equals to count plus 1. If majority not equals to nums of I, then count will be count minus 1 here. So what was our majority element? Our majority element was 3, but now 5 has been encountered. But since count was 1, okay, so we will simply decrease it. So count value is 0. Majority element has been the same. Okay, we have not changed it. So when we'll go to the next loop, there comes 2. Okay, so the same logic will be applied, but now the value of count is 0, right? So what you will do is you will simply change majority to uh, the number 2, as we have did in when we first encountered 3, since value of count is 0, and value of count will be changed to 1. Okay. Now when come to I equals to 3, again came element 2. Now the same logic will be applied here. The value of count is 1, okay, not 0. So if we can see what we did here, if majority element, if value of count is not 0, okay, and if majority element right now what we have is equals to the current element, then we will simply increment the value of count. Okay, we will not change majority element. So the value of count will be 2. Okay. Now when I equals to 3, 4 is has come. Now since value of count is not 0, okay, and majority element is not equal to the current element. So we will decrement the value of count. Majority remains the same. When I equals to 4, then it is 7. And value of count is, again with this logic, majority is still 2, current element is 7. It is not equal, so count will be decremented and majority remains the same here also. Okay. Now when we come to I equals to 5, okay, and we have got 2. So it is equals to the majority element, right? So the value of count will increase to 1 again and majority remains the same. And similarly, 0, 1, 2, 3, 4, 5. Okay. The element is A and count is incremented by 1. Majority remains the same. Okay. So in this way, every time you are going to get a majority element, you are not even sorting the array. Okay. You are just leveraging over the fact that it is given in the question that majority element always exists. Okay. So you just take first element as majority and take its count as 1. Go to the next. If it is not equal to the majority element till now, you will simply uh, decrease its counts. But once you have got some element which is different from the previous majority and the value of count is 0, then you will change the majority element. That is the simple logic. If I code it down for you people, it is like this.
Sir, I have a doubt.
Yeah, I'm just completing the code. Then I will take it out. Okay. Yeah, go on.
Sir, I have to ask that in this array, if there are two more elements like 5 and 6,
Okay.
then the majority element will be 2.
So how will majority element will be? This code will fail because it will always give majority element, right? And if there is 5 and 6 also, then the majority element will be 2. But does it, is your test case is telling with our condition that majority element always exists? Is there any majority element at all in this array? 2 is occurring for 4 times, 5 is occurring for 2 times. There is no majority element. This logic that I have told you right now will work only
Yes, sir.
if it is given in the question that majority element always exists. Otherwise, this code is wrong. Okay, you will have to apply some other logic, right? Is it clear to you?
Yes, sir.
Okay, fine. So let's see some another question. This is a next permutation. Okay, so you are given an elements of array. Uh, okay, of size n. Let's say num. Okay, you have to find the next permutation of it. So basically, you have to print the next permutation of it, or just change the array for the next permutation. So what I mean it By example, you can say here, like okay, so if you are given this array, so what would be the next permutation? That is asked. So next permutation would be 4, 5, 6, 2, 8, 1. So basically, just if we take it in arrangement, like if we are given 1, 2, 3. Okay, so what would be its next permutation? 1, 3, 2. What would be its next permutation? 2, 1, 3, then 2, 3, 1, then 3, 1, 2, then 3, 2, 1. Okay, so you can see how it is progressing. Okay, if you are given at any time in any array, how are you going to calculate the next permutation? Like for 2, 3, you are just simply you change it to 3, 2. It's more like consider one greater number considering only these elements given in the array. Okay, that is what next permutation means here. You can see the greater number than 132 is 213, the minimum greater number. Okay, these four all are greater than this one. Okay, so don't confuse it with the greater number and all. Just you have to see what is the next permutation. Okay, now if the given number is this, take one more example. Uh, 3, 4, 3, 2, comma 1. So what would be its next permutation? So in this case, the next permutation would be 1, 2, 3, 4. It will again go in the cyclic order. Okay, like it is the technically largest permutation possible with the given numbers. So for it, next permutation of it will be the starting point. That is 1, 2, 3, 4. Okay, so that is the definition of the next permutation. So you, if you are given an array, you just have to change the array to find the next permutation. Okay. So is question clear to you? First, tell me this.
Yes, sir.
Okay. So first you guys proceed. Okay. Then I will tell. I'm giving you time. Okay. So anyone who has thought of any idea how to approach this question?
Yes, sir. We can just start from the end and try to find and try to find the point up to which the sequence is increasing.
Okay.
Okay, then there are two conditions. If we reach the end of the array and we cannot find such a sequence, then
Mhm.
a next permutation does not exist.
Okay.
Huh. But if we do find it, it means that we have to just replace that element and the element before that while printing the array. Not, I'm not able to convey it well. Can I just
Uh,
show it?
yeah, yeah.
Okay. So you're given this array A1, A.
Okay, okay, fine.
So it's just given this array, and the condition for when the next permutation won't exist is that if
Mm.
all the elements from here are written in a non-increasing order.
Okay.
Because, okay. So what we have to do is just for a next permutation, we know that suppose we are given to here that AI and AI minus 1. So to
Mhm.
create a next permutation, we have to find AI such that AI minus 1 is less than AI.
Okay.
And also we have we have to find this from the end, and we have to find the first AI which satisfies this condition from the end to create the next permutation. It should be
Okay. So mm, I understood till this point that AI minus one is basically smaller than AI, right?
right.
Okay. So what will you do next? You have found AI and AI minus one.
So now we'll just have to print the first. We'll just print the array in parts. We'll print the array up to this point, which is index I minus 2.
Okay.
Then we'll print this element first and then this element later, and then we'll print the rest of the array.
But would it be right?
Uh,
Uh,
yes.
uh, Maybe I will show you. Stop sharing your screen.
Okay.
So for this case, AI would be 7. Okay. And AI minus 1 would be 6, right? So
Yes,
what
sir.
you just told that we should we should first print 11, then 4, and then 7, right?
Yes, sir.
And then you told first we'll print 6 and then 5.
Huh.
6 and then 5, 3, 2. Is that what we are saying?
Yes, sir.
So is it the next permutation? You are almost, but we need to see there's something. Okay, so what next permutation would be? 11, 4, then 7, then 2, 3, then 5, then 6.
Okay, understood. Then we'll have to print the rest of the array in increasing order.
Okay,
Ah,
so fine. Now I will tell it with everyone. So anyone else who has thought anything else apart from this approach? Okay, so I will tell you what this approach is about. So basically, when you are looking for next permutation, so first and foremost thing that you would look that if array is in non-increasing order or not. Like if it is given that let's say 4, 3, 2, 1. Okay, so for this, uh, if this is the case, then what would be its next permutation? As I told that it would simply be 1, 2, 3, 4. Like you will print the array from reverse side. Okay, so you will check here that if array is in non-increasing order or not. Okay, now let's say ki you will start from let's begin. 2n minus 1 I okay. For example, you just take one index as minus 1. Okay. So what this logic is doing is basically you started from this side. Like let's take this example for our convenience. This is the output. Okay. No, I don't think this is the output. 11, 4, 7, 2, 3, 5. Okay. So you started from this 2. Okay. First, then you check that if 3 is smaller than 2, no. Then you simply the loop traversed from reverse side. Then it came to 3. If 3 is if 5 is less than 3, no. When you came at 5, then if 7 is less than 5, no. When you came at 7, you check if 6 is less than 7. Then obviously here you find that 6 is less than 7. So you just store that index number. Okay, so you have got your point. Okay, like 7. So the what will happen here is basically you have find this index number. So for 0, for from index to 0, you let's see, for int I equals to 0, uh, I is less than equal to index minus 2 I plus plus. You simply uh, print this number. Okay, number 5. Fine. Like first you have printed it. What will happen is you have printed 11 and 4. Now you have to do something with this number 7, 2, 3, 5, 6. You have got this. Okay, 11, 4. Okay, now you have, sorry, you have printed this 11 and 4. Now you have 7, 6, 5, 3, 2. 7, 6, 5, 6, 7, 5, 3, 2. Sorry, 6, 7, 5, 3, 2. Okay, so you have got this 7. Okay, so now the next number that has to be printed is 7. The logic here is at the first time when you discover that there's a number which is greater than the number just before it, which is 7 here. So obviously the next permutation would have everything same till that number, like this index minus 2. And after that instead of 6, this 7 will take its place. Okay, so what I'm trying to tell you is we have 11 and 4 fixed. Now since 6 is smaller than 7, so the next number must start with 7. Okay, next permutation next permutation, the number after 4 should be 7. Okay, that is the logic, because at this point you have just encountered that it is less. Okay, now once you have this 7, 11, 4, 7, you have got. Now what will you do? One thing is for sure, that if you have reached till 7, then the number after 7 has been in decreasing order, right? So for next permutation, what would you do? We'll print the smallest number first. So what we'll do is basically we'll print from 2, 3, from the last element to this index plus 1. So what I'm trying to say is I equals to 0 minus 1, then equal to index plus 1 I minus 1. Okay, so once you have found this 7, okay, so after that, since the number after 7 has been in decreasing order, you just printed it from the rightward side till 5. Okay, 2, 3 and 5. Now what is the element that is remaining? That the element that was just smaller than 7, that is 6 here. Okay, so you will simply print that index minus 1. So this was the logic here. Okay, first you did was you are trying to find that index. Okay, if it is, you can put the condition that if index equals to minus 1, so then simply just reverse it, just print the array in reverse order. You don't have to do anything. Okay, then you simply did was you take from reverse side and you printed till index plus 1, and then you simply printed index minus 1. So this was the logic, and as Nishan told. Okay, so have you guys understood this question and this logic?
So what if the number at index minus 1 lies between the left out numbers after index?
So let's change it a bit. You are saying that
So we can just do a simple thing, right? If first we just print it from the last till we get that number, the number at position I minus 1, and then we print the number at I minus 1, and then we print the rest of the elements.
okay.
Okay, sir.
Right. Here the number which was just smaller than 8, 3 lies between some number after it. Okay. Thank you for pointing it out. Okay. And then I think this logic will, you have to make some little changes to this logic, although this case was missing. So what we will do in this case? Anyone? Like you have this index number as 8 here.
Sir, I think Nishant already told that we can check that we can start from the back and check if when the number comes, then we can print it and then continue.
Yeah, that is right. Yeah, so you should simply just traverse from right and check if it is smaller than 3, then you will print it. Once it is greater than 3, then you will print 3 first, and then you will simply traverse in that order. Right. Okay. That was great, Nissan. So anyone else who is having any doubt in this question? Okay, so let's move to some other question. It is longest sum contiguous subarray. So basically, the problem is given an array num of an element. So what basically I'm trying to say is it is number 7, 8, minus 5, 3, 4, 11, 6. Okay. So you have to find the longest sum sub array. The sub array has to be continuous. Okay. It can't be some disturbance. Yeah. You have to find the longest sum continuous subarray. So what would be the longest sum subarray in this given question? So just give me.
3, 4, 11, 6.
No. I think 3 4 the sum of 3 4 11 6 is 11 6 17 and 7 24. Right. But if we take this whole array as a subarray, whole array is also a subarray. Right. It doesn't have to be only subarray. Matlab, the whole array is also a subarray of basically the array num that is given here. So if we take the sum of all the element in this array, then it is 34. Now had it been, let's say, minus 11 here, okay, then what would be the output? Then the subarray would be 3 4 11 6, and its sum would be 24, right? Yeah, that was the case. So you are given this question, okay, you have an array num, so you have to find the longest sums continuous. So you don't have to find subarray, you just have to find the sum which is maximum in any subarray of the array. And an array can be subarray of itself as well. So try this question. Okay, so how are you guys approaching it?
We can just do with recursion. Suppose okay. So first हमें ये पता है कि अगर नेगेटिव एलिमेंट्स है तो उनको रिमूव कर देंगे स्टार्टिंग में, क्योंकि वो कंट्रीब्यूट नहीं करेंगे मैक्सिमम सम बनाने के लिए.
नहीं कर भी सकते हैं.
नहीं, जस्ट स्टार्टिंग में, एकदम स्टार्टिंग में जो
एग्जाम्पल.
अगर सपोज जैसे यहाँ पे 7 नहीं होता और सिर्फ -11 -5 होता.
अच्छा, ओके ओके, हाँ
हाँ,
फाइन.
तो एकदम स्टार्टिंग में उन एलिमेंट्स को रिमूव कर देंगे अगर जीरोस आएंगे या फिर -11 -5 टाइप्स आएंगे तो. हेलो.
But what if there are only negative elements in there?
If there are only negative elements in the array, we pick the largest negative element and the sub array will have just only one element.
Okay, so you need to consider that, right?
Right.
Fine. Okay,
Yeah.
yeah, go on.
Okay. So in this case, we just start with 7. So we are given two choices. Either for every element we can add it uh, to our like if we are forming a subarray, we can include it in a subarray, or we can just we can remove it and we can just hop to the next element.
Okay.
So we'll just implement a recursion to do that and we'll get the answer.
So how are you going to do it with recursion?
Okay, I haven't written it. I'll write it.
No, no, don't. I don't want code. I just want logic. Like how recursion is going to help in this question.
Um, so
You can do it without recursion also, right? Recursion would only make it a complex problem. You can do it in a simple for loop. Okay. We will see. Anyone else who has any idea apart from Nishant? Okay, so let's see how to approach this question. So we have to find the longest sum in a contiguous array, subarray, right? So just for now, assume it to be, let's say, longest sum has to be. You just assume some maximum negative number, okay, which is int min. Okay, so you assume longest sum to be this, and you take a current variable and you just initialize it with 0. Fine. So what I'm going to do is basically I will traverse the array every time and I will add the current element to my current. I will add the element encountered at that time with the current. Like if you see the code, uh, then you will simply do is equal to nums of I. Fine. So once you have done this, okay, what we will do is basically you will check if current is greater than longest sum. Then you will simply make longest sum equals to current. Okay, so this is one thing. Now it isn't complete as of now. So it could happen that let's say that if there are no negative number in the array, no, like if there is some positive number in the array. Okay, so you can just what you can do simply is you can check if the uh, if current element is less than 0. Okay, so then you can simply put uh, current equals to and current element is less than 0 and nums of I, which is basically the element we have encountered, is greater than 0. You can simply make uh, this element as no, wait, you don't have to do this. Just make current equals to 0, nothing else. Okay, now if you traverse it for this question here, as you can see, first you have got 7. Okay, at I equals to 0 there is 7, then your value of current would be 7, and then longest sum will be uh, current is greater than longest sum, so longest sum would also be 7, right? Then you came with I equals 1, then the current sum become -4. Okay, so now you compared this current sum with the longest sum, so it isn't the case. So basically what you will do is you will change your current to 0 and the longest sum be 7 as it was before. Okay, so there's some error in this logic. Can you guys tell? It will fail for some test case. I can see it. What are those?
If everything is negative.
No, no, that is a very trivial case. You can get all differently also. Apart from that, so basically, what will happen is when you have to include that negative number, then this case will fail. Yeah. Okay. Like here, when 7 minus 1, 7 in minus 1 is equals to basically negative number. So you were setting your current value to be 0. But what if it was to be included? Okay. So it would not be like that. There are some cases which would fail, and obviously that trivial one. But in this way, if you traverse it in further, okay, then you came with -5. Here also current will be -5. And since current is less than 0, after it you will change it to current 0 and longest sum has to be the 7 itself till now. Now when I equals to 3 came, then the number in counter is 3 and current is equals to 3. And you will compare it with the longest sum. Since longest sum is 7, so you will not change it. Okay, it would remain the same. Now when you came for I equals to 4, then came number 4, then current would be 7 here. Initially it was 3, so we will not change this to 0. Current is 7 and the longest sum would also be 7. And then y equals to 5, 11, current equals to 11, 7, 19, and longest sum equals to 18. When I equals to 6, then it is 6. Current equals to 24. And since it is greater than longest sum, we will simply change it. Okay. So this is how we'll proceed. And one thing that you should notice here is whatever longest sum we are taking, it is for only continuous subarray all every time. It is not like that we are taking 7 from here and 3 for 11, 6 for here and adding this. We are not doing that. With this logic, the basically the contiguous subarray that has been mentioned in the question is always maintained every time. Okay, so you are considering contiguous some element only when while traversing the loop. So this was the logic for this question. So anyone who has any doubt in this one? And there's one trivial case of negative element. Okay, so that you can check differently altogether. There's no issue. What would happen? We haven't taken any for negative element. So your longest sum would be int min. It would not change at all. Okay. So when let's say there is number called -3, -4, -6, -6. Here also, when your current element is -3, then it is obviously -3 is greater than longest sum. So longest sum was -3. Then when current was -4, okay, since it is negative, so you will change current to 0. Then again you will add this element, then current would be -4, and it would not be greater than the longest sum which was -3 before. The longest sum remain intact here also. So basically it is considering the fact that you are taking the largest of all the negative numbers. So I think that case will also be taken care of, right, Nishant? I think that case there's no problem for all if all the number are negative in this logic, as you can see from the code. Okay. So is it clear to everyone, or anyone has any doubt in this logic, or they want to suggest something else apart from this? No. Okay, fine. So I think for the array part, your next lab session is also on the array only. So there are more question array this week. Let's see what are the questions here. If anything is that is needed to be discussed explicitly. We are given an array. We have to function is sorted. So this is one simple question, check sorted. You just have to check if it is in increasing order or not. You don't have to do anything else, right? So I don't think you should have any problem in this check sorted. Yeah, finding duplicates in array. Okay, this is one good question. So you have to find duplicates, and your task is to print all the integers that appear twice in your original array. If no duplicate exists, print no duplicates exist. So how are you guys going to approach this question? Finding duplicates.
We can sort the array. That is one approach. Or if we are just given suitable constraints, we can create another array to store the count of every element that we encounter.
Okay, that is right. That is right. Yeah, that has to be the approach clearly. But without array also there is one approach. Okay, you should look for that if you can think. But that would be not that is not expected from you people at this moment. Okay, but the approach you told was right. Both the approaches. So yeah, it can be done with those cases. Next question, lowercase. So it is simply you just have to change that number and add 32 to that number basically. You know the ASCII code, right? Of every character in C programming. So the capital A start with 65 and small a start with 97. Okay, so you just have to add 32 to every number. So that will change it to lowercase. Or in Python or some other, there's direct, you can use direct function also, but you don't have to use direct function. Okay, you have to change it using ASCII code. Okay, is it clear to everyone? Lowercase thing. How are you going to do it with ASCII code?
Yes.
Okay. Now let's see. Check substring. You are given two string s1 and s2. Write a function which take two strings and return the start index of the substring of that. Okay, so first tell me some trivial approach, like how will you approach this if you have to check if a string is substring of or not of another string. Wait. This is the string and this is the substring, right? That you have to check. So one basic thing that you can do, the substring is going to be continuous, right? You just can't take for the case like if strish. So you can't call fish as a substring of this string, because if it has f and ish, it has to be continuous, right? For definition of substring. So you will take one element s as the start point, and since the length of the substring is 4, you will check the length of string. You will check the string from this first element of 4, and you will check if it is equal to the fish or not. Basically, you can do it character by character comparison, and once there's a mismatch between the character, you can simply understand that the substring is not going to start with the substring that is going to start with this number, the s here that we have assumed, is not going to be correct. Then what we'll do next, you will assume a starting point to be t, and then you will consider TARF. It is also not a matching with fish. Then you will start with A, then ARFI, that is also not a substring. Then you will simply start with R, that is also not a substring. Then there is FISH, fish. So you have encountered one substring, so you will simply return the starting index. There could be the case that there are more than one occurrence of the substring in given string, like here. Fish can also be this and can also be, but you have to output the starting point where you are encountered first time the fish. Okay, so that is one naive approach to this question, but there is some good approaches available. You can check online. Okay, there's some algorithms that is telling you how to check if a string is or substring of another string or not. Okay, when minimum time constraint. Okay, so I think you should look for that. But as of now, this naive approach is expected from you people. But if you have time, then do look for that approach. Okay, we'll get to learn things. Then there's pangram, at least once. It is also a simple problem. Like you have to check if occurrence of every English alphabet is 1 or not. So you can simply make an array of those total alphabets, and you will simply store frequency of every character occurring in the given string, and then you can traverse over that array, that if every letter of the English alphabet appears at least once or not. Okay, so it's a simple question of array. You just have to store the frequency of every character in that array, right? Then there is this Caesar cipher. Then again, what you have to do, this is telling you that Ci equals to Pi plus K mod 26 basically. So here also, if you take this question, then you have to convert it into the lowercase element. What you are doing, you are doing simply, you are adding 32 to the ASCII value of this character. Okay. So similarly, what you have to do is the same. Basically, you are adding a K element that you have to, like if A and there's 3 added, then A, B, C, D. The 3, if it is shifted 3 times, then it is D. Okay. So that has to be the case. Okay, and that is mod 26 is taken because there could be a case like there is z and you have to add 1 to it. Then the next number is 1 basically, not 27. So that's why we have taken mod of this. So it is simple since there are only 26 alphabet, and you just have to shift every character by the given number of k here. Okay, so I think you would be able to do it. It Okay, there's note also, avoid transformation into ASCII code. Okay, you don't have to transform it into ASCII code altogether. You just have to change it using that character only. That's what it is asking. Just consider this 32 to 127. Okay, you don't have to take 0 to 31 ASCII code because that is of no use for this question. Okay, because usually input would be in the integers, alphabets, I think. That is all. So anyone who has any problem with Caesar cipher? Fine. Let's see another question. The transpose of a matrix. Okay. So you can do simply is basically you have to change the column to row and row to column. So there are two for loop, nested for loop that would work for that. I think you have done some question on 2D array, right? There was one question in lab 7 or something, or it is the first time 2D array is given to you people.
Yes, sir, it was there for finding symmetric matrix.
Okay, fine. So okay, you'd be able to do it, I think. Or else you just have to use nested for loop in this case. You are given a 2D array. Each value of 2D array can be either suppose in dashes represent people and the value at row. I and column J is 1. In this case, I and J are 0. Okay, fine. So define text. Okay. Oh, so you have to count the number of friends here that. So whenever there is one, then obviously it would count for friend, but you have to take care that you don't count this one twice. Okay. Like if A and B are friends, so you will the number of pair would be one simply. You will not again traverse it for B and take that A as one extra case. So that one thing is needed to be care of. Okay. Else everything is easy in this question. You just have to count for one and check that the number one doesn't overlap for the same cases. That is it in this question. Now this challenge problem, unique occurrences. So occurrence of every element has to be unique. Okay. So for all other cases, it must return false. Right. Okay. So yeah, how will you approach this question? This is a good question, really. Unique occurrences in the challenge problem.
You can, I'm thinking of creating a map of a map. Suppose,
So has map been taught in your class?
no, but I don't, oh, okay, so मतलब map नहीं पढ़ा है, but okay, an array which stores the count of an array which stores the count.
Yeah. Okay, that is great. And you can again sort that.
Yes, sir, but that would be good as long as we know what the constraints are. If they are
Yeah.
too large, then it will create problems.
Yeah, you will have to create map for that. So I think that sir will discuss map with you people in few weeks, and then we can see some more questions related to map. Okay. So I'm leaving this challenges questions as of now. If you have time, do approach this, but try to finish this assignment and do check that algorithm for substring check. Okay. Then apart from naive approach, you will get to learn a really good algorithm. Apart from this, you want to discuss anything else? Okay. So yeah, I think we are good to go. If you have any doubt, then do post it in Piazza. We'll discuss it over and finish this assignment. Right.
Thank you, sir.
Thank you, sir.